Hello students, today we are going to start a new chapter in physics, work, power and energy. Now this is nothing new. You have studied in lower classes, in class 10 even, you have studied this chapter. So let's start. In terms of physics, what is work? Work is said to be done when a force applied on a body is able to produce a displacement. Work is said to be done only when a body acted upon by a force moves through some distance. Then we say that work is said to be done. Okay. So if there is no displacement, then suppose you push the wall or any standing truck and there is no displacement, so it means that no work is done, because work means the force applied on the body must produce some displacement, then only work will be said to be done. Now let us see the formula and how measurements of the work. So first of all, we'll deal with work by a constant force, where force is constant. So when we are talking of work by a constant force, work is measured by the product of applied force and the displacement in the direction of force. Okay. So what is the formula for work? Work means what? Force and the direction, displacement in the direction of force. If the displacement is in the direction of force, then no problem. Suppose here you are pushing the body this way, the body is also moving this way, then it is okay. Force, and as much, see the force, how much force you are applying and what is the displacement, just multiply it and you will get the value of the work done. But suppose in this case force is applied this way but body is moving this way, so there is an angle between the force and displacement. In that case, we will take a component of force in the direction of displacement, or we can also do one thing, we can take the component of displacement in the direction of force, either of this. So as it is seen here, this is F. So what we have, and this is the direction of S. Okay. So what we have done here, we have taken a component of F in the direction of displacement, that is F cos theta, which we have studied in the chapter of vector, resolution of vectors. So F cos theta is actually the component of force in the direction of displacement. So because the definition of force is that the force is the product of, the definition of work is that work is the product of force and displacement in the same direction. So what we have done here, we have taken the work, here we are taking the force in the direction of displacement. Acha. So now so what we will get F S cos theta. So what will be the work will be F cos theta into S is equal to F S cos theta, because F cos theta is the complement of F in the direction of the displacement. Okay. So F cos theta is the component of F in the direction of displacement. So that is why we have taken F cos theta into S, so Fs cos theta. And you know that Fs cos theta is actually the definition of dot product. So we can say work is the dot product of force and displacement. Work is a dot product of force and displacement. Now as we know that the resultant of any dot product is a scalar quantity, we know that resultant of any dot product is always a scalar quantity. So here also we will say that work is a scalar quantity. So work is a scalar quantity and thus work is a scalar product of force and displacement. So work is a scalar quantity and work is actually the product of force and displacement in the direction of force, or you can say product of displacement and force in the direction of displacement. Now let's come to unit. The SI unit of work is joule. Now what is 1 joule? If you apply a force of 1 meter on any body and that force is able to produce a displacement of 1 meter, okay, so you are applying a force of 1 Newton on a body and that force is able to produce a displacement of 1 meter, then what will you say? That the work done will be 1 joule. So 1 joule is actually what? 1 Newton into 1 meter. Now relation between joule and erg. 1 joule is equal to 1 Newton into 1 meter. So 1 joule, now a CGS unit of work is erg, and 1 joule is equal to 10 to the power 7 erg. Acha. Now nature of work done. See, positive work. So positive work means what? When the force and displacement are in the same direction. Okay, suppose you are pulling the body this way, the body is also moving this way. So then we say it is a positive work. Negative work, when suppose you are pulling the body this way and the body by anyhow moving this way. Okay, for example, if you throw a body upward, then work done by the gravitational force is negative, because gravitational force is pulling the body downward and the body is moving upward. Similarly, when a body is moving over a friction plane, okay, then what will happen? Then the work done by friction is also negative, because the direction of displacement is opposite to the direction of friction. Now zero work means what? Where there is no displacement. So there are two cases of zero work. In two cases we will say that the work done by a body is zero. First case, if there is no displacement, because simple rule na, work is equal to what? F into S. If S is 0, then W will be 0. And second case, if the Fs cos theta, if this theta is 90 degree, it means displacement and force are perpendicular to each other. If the displacement is perpendicular to the force, the theta is 90 degree. In that case, we will say that work done is also 0. So there are two cases when work done will be 0. First case when theta is 90 degree, and second case when the second case is theta 90 degree, and second case when displacement is 0. Yes. Acha. Till now we are studying about the work done by a constant force. Now let us study about the work done by a variable force. See, if the scenario is this, that the force is varying, okay, due to some way the force is varying. For example, when a rocket is fired upward from the earth, the force required to keep the rocket moving from the earth is not constant, it continuously decreases. Okay, so when the force is varying, suppose you see the graph, this is the force, the varying graph, the force is varying, and the body under the action of the force has moved from here to here. The displacement of the body is from x1 to x2. In that case, the work done will be what? Work done will be what? See, here we will find out what? x1, x2. So see, here we will divide this into small components. We will divide this into small components. Okay. And after that we will integrate and find the total work done. Okay. So please go through the video, and total work done will be found out by integration, that I will explain you later in the live class. Okay students, so till here, and we'll complete in the next chapter, next class.